Okay, just a couple blasts. Oh yeah. Dang. It's coming out good. Keep it going. Just on, off, on, off, on, off. Mine's coming out too. Right here. That's crazy how much oil's coming out of this. Today we have a base section that is not working. It's 69 degrees in there, and that's not good. But it's both sides. This is on a rack. It's got cold rails and base sections on the other side too. So it's a multiplex system. So let's get in here and figure out what's going on. All right, so back in here, this side has two coils. There's a coil there, and there's a coil here. And what the hell? Oh, that's rubbing out. I was worried about this, but it's a ground wire. We'll fix that. But I have the power running because we need to diagnose right now. But if we look right here, liquid line comes in through that solenoid valve, gosh darn it, and then it tees right down at the bottom there, and that tee goes over, and that's the liquid line for the other coil. So the fact that the whole box is at 70 degrees indicates that there's more than likely a problem with the temp control or with that solenoid valve. Looks like it sounds like it's opening. There's a screw missing from it, but it's magnetic, so the temp control is calling, but we're not getting refrigerant flow. I mean, I don't even need to put gauges on it. I can feel it. This thing is completely deteriorated really bad in there too. Huh. But yeah, since both coils, if it was just one coil, I would think it would be a TXV problem. But this guy, it sounds like it's opening, but there must be something stuck in there. Because that's the only thing that could cause just this side not to work. The other side and the cold rails are all working. So yeah, we've got a problem with that valve. Come up onto the roof. This is the compressor, and it's not running. It's not running. It was running, but all the other boxes are cold. So that to me indicates that that solenoid valve is not opening. But we're gonna gauge up and see what's going on with the actual pressures. Yeah, this guy is pumping down. It's like maybe that liquid line solenoid valve's opening just a little bit because everything else is satisfied, but it's literally, there, it just shut off. I mean, it was literally about to pump down. So what we're gonna do is we're gonna turn on the other systems and we're gonna pump down the refrigerant charge into the receiver, and then we're going to get that solenoid valve replaced, or at least open it up and see what's going on in there. Now I already loosened the packing on this. So all that we're gonna do is front seat this valve. It's gonna stop the refrigerant flow coming out of the receiver. The compressor is gonna continue to run, and it's going to pump down. So it's just because it can't come out of this king valve anymore, the refrigerant's backing up into the receiver and just slowly building up. Now, whenever you have these, you really should, I'm not always perfect, but you really should tighten these up because they do leak when you loosen the packings. So now what I need to do is go downstairs and open up or get the other systems to turn on so the suction pressure comes up. So that way we get all the refrigerant out of the low side of the system over there. So this side over here just turned on. It's at 39. So we'll leave the drawers open. It's starting to pump down. We just needed another solenoid valve to open up. There's one all the way on the other side too. Oh, fun stuff, right? See, the cold rails are frosting up. They're on that circuit also. I think there's also leaks in these that we know about. That's why there's a yellow marker right there. This whole system's a dumpster fire. But yeah, this side's frosting up too, so these are all working. Come up onto the roof, and it's just about to satisfy as it's pumping down. Might need to actuate the pressure control a few times just to make sure that we get everything out of it. So what's happening is it shuts off, and then the liquid in the compressor starts to boil out, and then it raises the pressure a little bit. You see we're at 6 psi. So that oil just stores that liquid, and it just kind of gets stuck in there. So every time it shuts off, it's actually doing pretty good now. It's not. Sometimes you got to turn the pressure control on just to get it a little bit lower. There we go. Okay, that's pretty good. Now what we need to do is go shut off the compressor so that way it doesn't run, and then open the low side to atmosphere. Okay, so now we're giving the pressure that we're going to build up in the system potentially when we start brazing a place to go, because we don't want it to come up and pressurize the system. We want the system open to atmosphere, but it's just the low side. So just the crankcase of the compressor, the suction line, all the way down through the evaporators and all the way back up to that king valve is open to atmosphere. It is gonna be tight. I'm gonna have to cut the valve like over here and take this swage joint off on the left to get it to fit in there, but we'll get it. Amazing, but it should work. Yeah. I guess I can cut it right here. Okay. There we go. Now it should unsweat. Try to figure out what plugged that thing up. We pulled out this solenoid valve and I could blow through it, which indicates that either we have a crushed liquid line or two bad TXVs or power heads, more than likely. So we're gonna try to see if there's anything we could do to put some nitrogen through that liquid line to see if it comes through. If it comes through, then we know we've got two bad power heads. There you go. Got anything? You got nitrogen coming out? Okay. All right, so it's two bad TXVs. Come on down. All right, so we blasted it with nitrogen up to the roof, and he can feel nitrogen coming out. So the odds are we've got two bad power heads. So I'm gonna braze this solenoid valve back in, and then we'll change the power heads and hopefully fix our problem. So the odds of two power heads, I mean, it's pretty odd, but I guess they don't pay that good attention on this side.
Maybe, but then it would iced up.
You would have thought, but they also don't open and close it a lot. Let me see though, maybe I can get it. Gotta be careful. That thing's hot. And then let's see if I can get this down into here now. Ow. Hot. There we go. It's going in. I like it. just want to make sure one more time we're going in the right direction before I braze this in. Yes. Okay. Yeah, be very careful not to twist that valve. Just cut the power head off. I know it's probably even got problems, but just cut the element.
I guess you'll know if it's that or not.
Yep.
So much oil in here.
Yeah.
Bubbling out.
Bubbling out of what? Oh, in the valve.
Yeah,
Yeah.
see?
Oh, you know
That's
what?
probably nitrogen.
Pull the bottom of the valve.
Pull it?
Yeah. Carefully. Pull that second nut, and we're going to drain the oil out.
This
So
one
pull
here.
the valve and pull the second one very carefully. Keep it straight when you pull it down because stuff's going to fall. It's actually really odd that you'd have two bad power heads. Now you can tell when you cut it.
Yeah.
There's nothing, no spray, so yeah, that's an indication of a bad power head. Now, what we'll notice though over there is that there's a bunch of oil. So, and we have those problems with these racks. So we're gonna try to drain the oil out of the valve. It'll probably be okay if you can't get it open.
I don't really want to, because I'm starting to bend it around.
Now, are you using, because look at, like I'm using the leverage.
I don't have that much leverage though as you do.
Can you turn your wrench?
I got this. This is how much I got right here.
And you can't get them any closer?
No. Try this. Further away now.
So Will got his off over there, and it's draining a bunch of oil too. So we're just gonna let that drain out, and it's just draining out the bottom of the coil. This happens on these multiplex systems with the big compressors. Oil gets trapped down here, causes problems. But all right, well, we're gonna assemble the valve, put a new power head on it, and then get upstairs and change the dryer and vacuum it down. I am confident that there's other leaks. I know for a fact, so we are not gonna get a great vacuum on this. I wonder if we need to like nitro it.
Probably coming out of the evaporator.
Why don't you go get some, here, take my nitrogen and put it in on the low side.
Okay.
It's not gonna go anywhere but here.
Yeah.
So yeah, put it in on the low side, let me know, and I'll leave mine out too. Just put the towel, no, that's fine right there, just like that. And because I can always like plug this one up and it should come out. So you're just gonna take that low side hose that's off.
Yeah.
And put it on there at test and just a couple blasts, and then just call me. So we are gonna backwards blast this from the suction, the low side that I took off at the gauges. Will took the nitrogen up there. We're gonna give it a couple blasts to try to push some of this out, so it'll be coming back through the coil, potentially pushing it out. And I can always like plug this one up and then go plug the other one up to try to get some of this oil out of these coils. All right, are you ready? Okay, hold on. I'm going to plug up my side, and then we're going to watch your side and watch it come out. Okay, just a couple blasts. Oh yeah. Dang. It's coming out good. Keep it going. Just on, off, on, off, on, off. Mine's coming out too. Right here. That's crazy how much oil's coming out of this. Hold on, I'm gonna plug mine up again because yours seems to be worse. Go ahead. I call this compressor killer system. That's what happens. It's because you have a 2-3 horsepower compressor in the wintertime.
Yeah.
Okay, and you know you've only got 1,000 BTU coil.
Yeah.
And the velocity's not there. So the oil makes it down here, but the velocity doesn't go through the coil fast enough to bring it back. So clean up all your parts, put the bottom of the valve back on first.
And then put the pins in.
And then put the pins in, then the power head. But wipe everything down. Oh, that's fine. I just had these right here.
Oh, the pins.
Pins, yeah, going down. That's what I'm more concerned about. It can also be caused by the power head, not, you know, because it doesn't just die most of the time, it slowly dies.
Yeah.
So that could be part of it too. So when it comes to unraveling the valve like I did, I don't unravel the last part. I leave that hooked and then I start looping the power head around. Because that last part is the most fragile part of that power head. The more you move that, more chance you have of breaking it off.
Okay.
So, and then we're going to use leverage to tighten this valve. There you go. One more quarter turn. There we go. Okay, valve's tight. You want to go ahead and head up and start changing that dryer?
Yeah.
We don't need to necessarily change the sight glass. There's nothing nice about these coils. They're a dumpster fire. So I'm gonna get that drain cleared out really quick and then we are going to go change the dryer up on the room. Now we know this system has leaks. It's not gonna be ideal, but we still do our best. We changed the dryer, put a new Sporlan catch-all, 16.4 flare. That way, super easy, we didn't have to bring the torches up, and now we need to go to the other side. We're still pumped down. We're getting ready to pull the evacuation, but I'm gonna pull the Schrader core out of here. I've got the new VC2G from Fieldpiece. The cool thing is it has a sight glass, so let's pull this last, make sure this doesn't come undone. We pull this last bit, and it has the sight glass so you can see it come out. There's the Schrader right there. So that's kind of cool. Valve it off, pull this off. Now remember, you know, sometimes Schraders are damaged, so sometimes they don't come out. I'm not gonna say that, you know, it's always gonna come out, but pretty nice to be able to see it instead of having to actually test it. So now we're gonna hook up and pull the evacuation real quick. We are not doing an ideal evacuation because we're pulling through a 1/4 inch hose just through the low side. But here's the thing, this system is pumped down. The king valve and there is refrigerant in the receiver and there is refrigerant in the discharge side of this compressor. The king valve is stopping us on that side. The internals of the compressor are stopping us on this side. None of that is 100% leak proof. So even if, you know, well, no, you're just not going to get a perfect vacuum on it. And you just need to understand that. We try our best, but on a system like this, we also know it has refrigerant leaks. So, and some of the refrigerant leaks are not repairable. They have to replace equipment. So we have to do our best to dehydrate the system. But understanding that it's not going to pass a decay test. It's just not. Will is opening up the king valve, and that's allowing the refrigerant to flow back through the system. It's going to come into the low side, right here, come through. There we go, we're coming back up, and it will turn on in just a second. There we go, we're back on and running. And then now we're gonna watch the system operate and go downstairs and verify that both of those coils are now cooling. All right, so we get in here. Both of these, I can feel them feeding now. The coils are getting cold, refrigerant's flowing through, and I can hear that one. You can actually see it right over here. So yeah, both of these are working now. So we're gonna put the covers on and finish up top. All right, last but not least, we gotta set this control 36 with a 4. It's already calling. We're cool. All right, now we need to go back upstairs, make sure we're still running, but yeah, it's already blowing cold air, so they're gonna be super stoked. This guy's already down to temp. We're frosting back to the compressor. Everything's looking good. Now we're gonna clean this refrigeration rack because it's dirty. And this is a very complicated one because they have roof leaks underneath here. And the roofer came and sealed the rack down to the ground. So it's a nightmare. So we got a vacuum up here, and this is a 2-person job. You got to vacuum just as fast as you're spraying it down. This is a pain in the butt. But we're gonna take the gauges off, shut it down, clean the whole rack really quick, and then hopefully be good. So the rack has a bunch of little holes in it, and that's just normal, right? That water drips down, and then this plate right here, this galvanized sheet, curb, whatever you want to call it, is rotted underneath. Now we've brought it to everybody's attention that we're supposed to. They need to fix this problem. They haven't, because the solution is to lift the rack up and replace the curb, and they haven't wanted to do that. It's a big ordeal. So I informed the management, we have to clean it. There's potentially going to be a leak, but we're going to try to mitigate it as much as possible because we got the shop vac. So we're going to rinse them, vacuum them, and work our way through. It's inevitable there's gonna be some leaks, but we can only do so much to prevent it. So all that we're doing here is pre-rinsing the coil, getting the big chunks off from the bottom, then we'll spray it from the top, and then we're just trying to vacuum it up as fast as possible. It's inevitable it's gonna leak. So we're just trying to be quick about it. Use some of the blue brightener. We got it all pre-rinsed. We're vacuuming, and now we're gonna put some brightener cleaner on it. It doesn't take much because it's fully concentrated, or it's really concentrated. And we're just gonna keep vacuuming. And again, it's inevitable that water's getting underneath, but we're trying our best. So the coil cleaner, we're using their coil gun so you get the right concentration out of it. It's from Refrigeration Technologies, the Viper foam gun. And we're just spraying this in and letting it sit for a minute, and then we're gonna rinse, and you can see it coming out pretty good. So not good for the vacuum to suck up the cleaner, but you gotta do what you gotta do. From this side, try not to get it in too much sensitive stuff. Try not to get it all over Will either. All right, we're not gonna get much more than that. It doesn't take much more than that. Now we just gotta do a really good rinse. It is really important that you get all the ends and you rinse all this coil cleaner off, because it'll just sit there and eat away at the copper. Just etch it down until it has refrigerant leaks. So you gotta be very careful when you're using the blue cleaners. But this guy just had so much buildup that it was necessary. So we're just doing our final rinse. We'll do another rinse from the bottom really quick to make sure we got all the big chunks out. And then we're just vacuuming. So not too bad. Turned out pretty good. We'll see the bottom results here in just a minute. It's pretty good from down here. It's a lot better than it was. It was cake full of stuff. So we're good there. We still got to clean out the trough. It doesn't look like it's draining very well wherever the exit is. There's a big trough on the top, but that's fine because I'd rather it drain when we have the vacuum underneath it. So we're gonna get this all kind of cleaned out first, and then we'll work on getting the trough cleaned out. We're getting ready. The condenser fan motors haven't started yet because they're off of temperature. So we're turning them on one at a time, giving them a couple seconds, making sure they're starting. I can hear them start. And then we will, they should all be running. There was 2 of them though that I didn't hear. That one's not running yet. That one's not running yet. This one's running. This one's running. This is the one we just worked on. Sight glass is nice and clear. Even though it has a wet condenser, that's a good sign. This one's running. That means that the flooded charge is correct if it's clear when it's this cold and wet. Yeah, we're looking good on that. This one's running now. Sight glass, I know it's hard for you guys to see, but it's clear. This one's not running yet. It's probably in defrost or something. This one's running. It's got a clear sight glass. Let's see if anything's in defrost. No, it's 927. Pretty accurate, pretty accurate. Make sure. All those. No, nothing's in defrost. The walk-in freezer could just be satisfied. But everything's back on. I'd really like to see the walk-in freezer come on though. But we're looking pretty good. We're just vacuuming out the remainder. All the condenser fan motors are running, rejecting heat. right direction. These ones don't work. They're old ice machine condensers, not in use anymore. So we're looking good. We're just gonna let it run and finish vacuuming up. All right, we dried it out about as good as we can get it. This side's a little more difficult, but it's fine. There's a little bit of trash in here. We tried to dry around as much as possible too. You can see the stuff that's coming out of that. It's just pure sludge water. But yeah, we did our best. There's only so much we can do with this. So unit's running. We're just gonna make sure everything comes down to 10. And last but not least, we are putting some oil in this guy to compensate for what's stuck down in the coils and what we drained out. So we're just waiting. It had just satisfied, so I'm waiting to turn it on just to see where the oil level is. It was really low earlier when it was running, but I had to go get some oil because I didn't have any in my truck. So just wait. And it's right at the bottom of the sight glass, so I'd like to see just a little bit more, but we're gonna give it a minute of running to make sure it doesn't come back or anything. Yeah, I'd like to see it just a little bit higher in that sight glass when it's running, so put just a little bit more. Not much. I'm just doing it while it's running, just adding a little bit. Probably pretty good with that. We don't want to go too crazy because we might still get some oil coming back. So I think that'll be good for now. It's about just under the halfway mark on the sight glass. So that should be good. Walking into these service calls, you kind of never know what you're going to get, okay? This one, you have to start using logic, and understanding the way that the system operates really helps you to use that logic. So I know that this is a multiplex system, okay? And it's on a rack. Okay, for all the people that are going to freak out, I know this is not a parallel rack, right? But this is a refrigeration rack. It's an enclosure that has multiple compressors, multiple condensers, multiple fan motors, okay? But regardless, it's on a rack and it's a multiplex system, meaning that there's one compressor with multiple circuits, multiple coils, multiple temperature controllers, multiple solenoid valves, okay? And each temperature controller controls 1, 2, or maybe 3 different, evaporators. In this situation, the only side that was down was the side I was working on. The cold rails were all working, which have their independent solenoid valves and temperature controllers. The other side has 3 evaporator coils with 2 temperature controllers. Those were all working too. So you have to start thinking logically. Okay, if all of those are working, they're down to temperature, the refrigerant charge looks correct, what else could it be, right? So you start, working your way through the problem. In this situation, I started thinking, okay, what are the odds that 2 power heads are bad? I mean, it's possible, but that's kind of strange, because for 2 power heads to be bad, one coil more than likely would have had to have gone down, and then the other one would have been running the box kind of halfway, maybe not great for a long time, and then eventually that one would have gone bad, okay? So I kind of focused on the solenoid valve because that was the common denominator. There's one solenoid valve for 2 evaporator coils, so that was the common denominator. We knew the solenoid valve was energized, so my first item to attack was that solenoid valve. So I pulled the solenoid valve out, and I think it's really important. Once I got the solenoid valve out, I tried to prove my theory. And when I put a solenoid magnet on it, I could blow through the valve. And it's like, wait a minute. That might not be our only problem. So instead of just brazing in a valve and moving on and then having to troubleshoot the rest of the problem, I went ahead and grabbed some nitrogen. We went up onto the roof and we blew nitrogen through the liquid line. Or I'm sorry, we blew nitrogen through... through the liquid line. Yeah, that's right. I was sitting here rehashing the call. I had my other technician up on the roof. He pulled the liquid line filter dryer out, which was a flare. Then I blew nitrogen through the liquid line and he could feel it coming up. Okay, so then that tells you, okay, the liquid line's clear, because it could have been a crushed liquid line too, because this runs through a intricate little passageway that sometimes ice can build up on the suction line because of the cold rails, and weird stuff has happened where it's crushed liquid lines and stuff. So that wasn't the case, right? So then it's like, okay, this has to be a power head issue. So my experience, the way to test a power head, once you're pretty darn confident that it's bad, is cut the sensing element. If you get gas, liquid refrigerant coming out, that's a pretty good sign that the power head was good. Doesn't necessarily mean it's perfect, but it's a pretty good sign. In this situation, we got no gas out of either power head when we cut them. So then it's like, dang, we have 2 bad power heads. Very odd to have 2 at the same time on the same circuit. You would think that the customer would have noticed 1. And I left some of the banter between Will and I, my technician, and you could kind of hear, Will logically going through in his head, well, if it was 1 power head that was bad, don't you think that the coil would have iced up? And the theory behind that is that you have 2 coils that run that entire box. If one of them goes down, then the other coil has to work extra hard to cool the entire box. And so typically when that happens, you start to see the one coil that's working freeze up because it has to run so long and get so cold to try to satisfy the entire box. So in theory, that would have been logical, but for whatever reason, we didn't see that issue. Who knows, right? But I did kind of mention that that box doesn't get opened a lot. They don't use it a lot. It's more of a storage box for like needed items when they're making things. So, it's possible that one coil was down for a very long time. In fact, that's what I think happened. One coil had been down for a very long time. It had been running off of the other power head, and then eventually that one went bad, and then it led to the problem that we had, okay? But we didn't just stop there. When we started to take the power head off, we started to notice oil bubbling out of the TXV. And it's like, wait a minute, okay? So again, experience starts to kick in. And when I start to see oil coming out of those TXVs, I've changed them before, and then you have problems because that oil will actually get logged in that coil to the point that it doesn't allow the refrigerant to flow through. Because, like I said, this system, the way it was originally designed, I call this a compressor killer system, okay? It constantly logs the oil down in the coils. And the biggest issue is there's so many intricate runs of 1/4 inch and 3/8 inch copper, and it's just not piped correctly, okay? There is suction P-traps on the riser going up, like all that's there, right? And there's no room to add another riser. It's such a horribly designed system. This is what we run into. So every couple years, we run into the problem where we got to drain oil out, put oil back in, and that's what we did. We drained it out as best as possible. Now, there's going to be, I can guarantee you, oil stuck in the other coils that we didn't work on also, okay? That's a given because I had to add quite a bit of oil to get that sight glass back up to a reasonable level, and, that's a problem, right? So we're going to have to deal with that when the time comes. So again, remembering this stuff, right? Muscle memory. So that way when we go to work on the other side, we know like, hey, you know what? If you ever have to like totally change a TXV, you got to keep that in memory because you could have flame outs. You could have, when that oil ignites, it'll flame out. It just wreaks havoc on the system. And, I know there's going to be some people saying, hey, well, why don't we solve this problem? That would be great if the customer wants to solve it, okay? Perfect solution is repipe the entire system, which is impossible because this box is all encapsulated with stainless steel. It's just not designed right. Put a digital scroll compressor that could vary capacity when there's no load. That would be a huge thing. And then also add oil separators to the system, right? But that's just money that the customer doesn't want to spend. So, we either go through compressors or when we're doing repairs, we start paying attention to the oil. We drain the oil out of the bad spots. I know it sounds super counterintuitive, but a lot of times their budgets don't allow. And so this is just part of the process of going through the system. Now, I can promise you that the first time I ran into this problem with these oil logged coils, it wasn't an easy fix. And it was a complete epic disaster because I wasn't ready for it. I didn't know that that's what was going on, but I've had it happen enough that I'm aware of it. And when the time comes, we know. And I also know that once we start to see enough refrigerant leaks on these systems in the evaporator coils down below, that you're better off just changing all the evaporator coils because personal experience, you start to take out a TXV or you start to take something out and then it's just like there's oil everywhere and it's so hard to braze and it's just a problem. So, you got to keep that in mind when it comes to diagnosing things. Now, I also mentioned that this system has a lot of refrigerant leaks. It has refrigerant leaks in the pan chillers. And the pan chillers, some of them are repairable, but man, are they a chore. You have to literally disassemble the stainless steel the way that this box was not meant to have those pan chillers taken out. It was assembled and all put together and never meant to be taken apart again. So, it's a pain to fix leaks in the pan chiller or the cold rail sections. So that's why I mentioned that there's some leaks that the customer, we've been telling them like, you guys got to start considering replacing this equipment, but The problem is this is a custom stainless steel island. All like everything's built into it. Heat lamps, soup wells, multiple reach-ins. This thing's like 30 feet long. They literally built this building around this. Like, it's just an epic disaster. So in order for them to change the entire island, go with self-contained, do all that kind of stuff, they're literally going to be shut down for a week. They'd have to deconstruct, cut the thing up into pieces, take it out in pieces. There's electrical panels going into it. You know, don't get me, I mean, whatever, you already got me started on it, but a custom island like this, they're such a horrible design. It sounds great on paper when the architect, the engineer come up with this design. We could save you money, we could put it all together in one unit, but the problem is 25 years down the line, 30 years down the line, when you start to run into these problems and you realize that it's time to start considering replacing individual units, you can't. You have to take the whole thing apart. And it's just such a bad design. But this goes to show that sometimes the engineers and the architects and the people that come up with this, and I'm not saying they're all bad, but sometimes they have good intentions. Hey, we can save you money if we build this custom unit, but they don't think 30 years down the line when it's time to start replacing equipment. And now the restaurant has to shut down for a week, 2 weeks to have all kinds of stuff done to be able to go in with self-contained or, you know, just individual remote units. It's an absolute disaster. And that's why we have this compressor killer system. So we just know what we have to do when we run into these problems. So hopefully you guys like the video. This is a common thing that I run into every couple of years where we have to do these kind of repairs. I'm not, you know, this perfect technician that has the answers to everything, but I've made enough mistakes that I've learned from them and started to pick up some cool things. So I really appreciate you guys. Thank you so much for coming to the video. If you're interested in any of the new cool tools that I'm using in the video, go check out TrueTechTools.com. I have an affiliate code set up with them, big picture, one word. If you use that at checkout on majority of the items on their website, you'll get an 8% discount, and then I get a small commission. So it's a great way to help support the channel. But you know what? The easiest way to support this channel is literally watch the videos from beginning to end. That really is the easiest way. You can also support it via PayPal, Patreon, YouTube channel memberships. There's links in the show notes for those. You can go to my website, HVACRvideos.com. We have merchandise like these hats available, t-shirts, beanies, sweatshirts, all that good stuff. We also have flat bill hats, dad hats. You know, these hats, I put a lot of effort. I've talked about it before. The black underbill is my favorite part of this hat. The other thing is the HVACR acronym. You know, it's not advertising HVACR videos, it's advertising the acronym HVACR. So a lot of people will still use these hats and they don't violate uniform policies at some companies. So pretty cool thing. They're a flex fit, they're breathable. So in the summertime, you don't sweat as much with them because they're a breathable material, but it's not a trucker hat. So check it out, HVACRvideos.com. I really, really appreciate you. Thank you so very much. Any feedback, leave me a comment or shoot me an email to hvacrvideos@gmail.com. And we will catch you on the next one.